Okay, let's give you guys some more practice. So here we've got a graph of y equals cos of x. Looking at this purple area, we are going to rotate this 360. We are going to rotate this 360 along the x equals pi over 2 axis. So when you rotate it 360 along this axis, you will trace out a 3D solid. Work out the volume of this 3D solid. Okay, and then the second part of the question is we're going to also rotate it along the x equals 0 axis. So we're going to also trace this 360 along this axis. So this will also give us a 3D solid. Also work out the volume of this 3D solid. So two questions, one rotating along this axis, and the second question is we are going to rotate it along the x equals 0 axis. So which will give us a bigger volume? Okay, so well, anyway, work out the volume of the two. One along this axis, the other one along the x equals 0 axis. So press pause and have a go. Okay, so let's tackle the volume along this axis first. So so the volume of, let's give it a name, volume of pi over 2 axis equals. So we're going to sum up all the shells along here. So if you look at this one particular shell here, the thickness associated with this will be dx. So our integral will be from, we remember we're summing up all the cylinders or all the shells from 0 to pi over 2, from 0 to pi over 2, and it's going to be something dx, because we are going to sum up everything and we're moving in the x direction. So let's look at this one particular. So we are summing up everything here. Let's just look at this one particular shell here. So looking at this thing here, the thickness here will be dx. We're going to revolve it 360. That will give us this cylinder thing. Okay, this cylinder thing here. So we will need to know the radius here. Well, the radius here, remember the volume will be given by this, from 0 to pi over 2, and it's going to be something dx here. So we will need to know the radius here. Well, the radius here will be from here to here, which is pi over 2, and then as we're moving along in the x direction, we will need to take away this distance here, which is x, and then we will need to 2 pi r it to get the circumference here. We will need to 2 pi r it. So that this here will give us the circumference, and now we need to times the height of the cylinder. We will need to times the height of the cylinder. So we will need to times cos of x. Okay, dx. So this here will give us the volume of this 3D solid revolved around pi over 2 axis. So the volume would be given by this. Will be given by this. Okay, so now it's just a matter of integrating this. Well, integrating this will take you to here, and then because 2 pi is a constant, and then looking at this, by now you should realize that you should use integration by parts. So if you make this to be your u, and then later on u prime will become easier and easier. So looking at this here, make this to be your u. While integrating using integration by parts, it will take you to here, and then it's blah blah. That will then take you to here, and then blah blah. That will then take you to here, and so the volume of the volume is given by this. Okay, and the second part of the question was us revolving it around the x equals 0 axis. So using this. Well, it's the volume is going to be given by this, and then this is a constant. Take it out. That will then give you this, and then it's blah blah. Overall, the answer will be this. Overall, the answer will be this. Okay. Just something to point out. When you're here, when you integrate this, it will give you negative cos of x. If you really think about it, you can actually take this out and it will still make sense. So this thing here will take you to here. But you would need to think about it. Even though you've got a negative in here, you can in effect take it out. Okay, but overall the answer would be this. So yeah, so that's your answer here. Okay.